Elements. Have you ever wondered what things are made of? For example, a table might be made of wood and nails. Your bread might be made of wheat, salt, and water. But what are wood and nails made of? What makes up wheat, salt, and water? What makes you and everything around you? About 2,000 years ago, people were asking the same questions. One idea was that everything was a mix of 4 basic properties: hot, cold, wet, and dry. They thought if you had just the right mix of hot and dry, that would make rock. A little less hot and a bit of wet might make wood. The right amount of all 4 properties might make a leaf. Pure samples of the 4 properties were believed to be air, fire, earth, and water. These 4 things were thought to be the elements that make up everything else. By the 1800s, some people had a different idea about what things are made of. Chemists were busy investigating many substances. They heated substances as hot as they could. They put acid on them. They ran electric currents through them. Sometimes the substances separated into new substances. When this happened, scientists tested the new substances with heat, acid, and electricity. Some substances would not change anymore. They called the unchangeable substances elements. The new elements had different names than the ancient elements, and there were many more of them. The new elements had names like iron, copper, carbon, oxygen, sulfur, and gold. An element is a fundamental substance. It cannot be broken into simpler substances. Elements are the building blocks of matter. They combine to form all the different substances in the world. By the middle of the 1800s, about 60 elements had been discovered. A lot was known about them. Scientists knew some of their chemical properties, such as what elements they combine with. They knew some of their physical properties, such as the mass of standard samples of the elements. When scientists listed the elements, they put them in order by mass, starting with the lightest element they knew about, hydrogen. The first periodic table. In 1869, a Russian chemist named Dmitry Ivanovich Mendeleev was writing a book about the elements. He made a set of element cards. Each card showed an element's name, symbol, and everything that was known about it. He put the cards in one long row from lightest to heaviest, hydrogen to uranium. Mendeleev saw something interesting in the line of element cards. The first 2 elements, hydrogen and lithium, had similar chemical properties. And as he looked down the line, he also noticed that sodium and potassium had properties like hydrogen and lithium. The similar chemical properties showed up periodically, meaning at regular intervals, in his lineup. Then Mendeleev saw that beryllium and magnesium and calcium all had similar properties, but different from hydrogen and lithium. The similar chemical properties of beryllium and magnesium and calcium showed up periodically too. Mendeleev tried all kinds of things to make the cards line up better. He began moving elements around. When Mendeleev moved titanium and its neighbors to the right, 2 things happened. The chemical properties of the elements lined up better, and there was a gap in the table of elements. Mendeleev predicted that an undiscovered element will fill that gap. He also predicted the properties of the new element. By lining up the known elements by their properties, Mendeleev predicted about 30 new elements. Over the next 30 years, most of them were discovered. The modern periodic table of elements. The modern periodic table of the elements organizes and displays all the elements from simplest to most complex. Hydrogen, the simplest element, is number 1. Mendeleev's idea of putting the elements in rows under each other so that the chemical properties are similar in the columns is still used. There are 2 elements in row 1, 8 elements in rows 2 and 3, 18 elements in rows 4 and 5, and 32 elements in rows 6 and 7. This is the modern periodic table of elements. This layout makes the table very long. Often, 28 of the elements are pulled out and shown below the others. Then the table fits better on a standard piece of paper. Color helps show which elements have similar chemical properties. In the periodic table used in this course, elements that are color-coded with orange, light blue, dark blue, light lavender, dark lavender, and yellow-green are metals. Green, red, yellow, and aqua elements plus hydrogen are nonmetals. The green elements on the right are called noble gases. They are interesting because they do not react with other elements.